So, hello friends, hope you are doing well. Today, we try to discuss on a very fundamental topic. As you know, we generally discuss on the fundamental and very basic topics on the machine learning till now. So, today also will be our following lecture based on this line, and our topic will be the cost function of the regression. So, this fundamental topics is generally asked in various interviews. So if you are preparing for interview as well as learn the machine learning, then you have to know these topics very well. So the cost function of the regression will be our topic for today's discuss. So let's start with agenda of this video. First, we try to define what is the cost function. Or particularly on regression, but in general, cost function is define all other problem or modeling also, just like classification problem or regression problem, anything. Second thing is why we do use it. And third, the different there is actually different type of cost function in the regression. So we mentioned that types of cost function of regression analysis. With their formula, graph, and advantage and disadvantage. And the last do we will do the demo code demo code for those different types of cost functions. So let's define the cost function. So in my previous video, I explained how the regression works. So let's start a plot. Let this is x, this means independent variable, for the dataset, and this is dependent variable. And these are our data points. Let's say the regression problem is we try to fit one line, or it can be plain or it can be curved, for different type of regression. I discussed this previous video. So if you not watch that, so please go to the video and just watch them. So as here, this is for simple regression, simple linear regression. Here you see, we try to fit a line to predict our dependent variable. This is actually main motive for the regression. Then what cost function do? Cost function is the mathematical formula which derive which uh, which calculate which is calculate by the difference between actual value and predicted values. This is actually the cost function. That means, so let's say our actual values are, let's say 257, and if we predict the predictions are, let's say 2.1, 4.8, and 6.9, then the cost function will be like, let's say the difference. So first take their difference, and then take their difference, then take their difference, that is 0.1, that will be 0.2, that will be 0.1. Okay, so using those values, combining those values, we calculate the cost function. So now, why we use the cost function? Why? In my previous video, I discussed on the R2 score, R square score, or adjusted R square score. There, generally do the performance metrics for a metric for a uh, machine learning model, ML model. That means how model is good or bad, such type of things. But by the cost function, by this cost function, we can optimize our model, our ML model, such that it can predict as much as good. Okay, so our prediction will be similar to the actual. So by to optimize this type of cost function, we can do that. So cost function is actually, so when you try on a any model on the machine learning or deep learning, so first you try to focus on what is the cost function of the model, because generally in interview they always ask what is the cost function for a particular model which you have used in your a project which you put in your resume. So cost function is highly asked questions for the interview. So you must know that. Okay? So this is actually part why we generally use the cost function. Now, what are the cost function in the regression? We try to find that. So different types of cost function in regression. So there are fundamentally three types of cost function there. First one is called MSE. We generally use that one. Maximum machine learning a learner or a user generally find this MSE. Its full form is mean square error. Then the RMSE, which is nothing but the root of the mean square error. So root mean square error. And the third one, MAE, mean absolute error. So as you see here, cost function is nothing but the function of the error. So cost function is really the formula with combination of of error. This is actually uh, the definition of the cost function as you see here. So let's discuss one by one, and there are some advantage and disadvantage also. So first we discuss MSE, mean square error. So mean square error is we calculate as, so as name suggests, you see here. First we take the error. So how do we find the error? First, error is y actual minus y prediction, where y is the actual value and y cap is predicted value. This is the error. Then take the square. So the formula will going on MSC equal 1 by n summation of I equal to 1 to n yi minus yi cap whole square. Where where n is number of data points in dataset. So this thing denoting the mean part, this is the square part, and this is the error part. So mean square errors. This name as suggests to that. As you see here, it is a quadratic form. That's mean the square is degrees. So if we plot this, the, the graph will be parabolic. Curve. If we plot MSE, and it has this curve has also one very interesting features, that is this curve generally going to convex, and in the convex curve we got some results that are it has unique maxima and minima. So we just focus on the minima part, unique minimum, minimum point, minimum point. Here, as you see, the minimum point is, so there is no more minimum point. So there are another non-convex curves is there. So if we got the non-convex curve, let's say this type of curve. If this is this these those are the minimum. More than one minimum point is there. But in the convex, there is only unique minimum. So MSE, so for that reason, generally we do MSE lots to define the cost function for the regression. So the some advantages here is advantages are, let's say, it is convex, so it has unique optimum optimum unique optimal point. Second one is, you can see as, it's differentiable. So for that reason, we can use gradient descent to optimize it. But it has also some disadvantages also. What are the disadvantages? First of all, it's not same unit at data, not same unit as data. Another disadvantages, it's actually not robust to outlier. Let's draw a picture. Let's say our points are those, and this is our prediction line. If we have some points here, then you see the error is actually very high. And after taking this error, when you square it, it's going to very high. So when we want to optimize the cost function, then it will takes time to minimize it. Okay, so it's actually not robust to outlier. Now here, to overcome these two type of disadvantage, we use first, to overcome this advantage, we use RMSE, and to overcome this disadvantage, we use MAE. How? How? Let's go to the formula for RMSE and MAE. Now, RMSE. Let's mean root mean square error. What is the formula? This is nothing but the root of the mean square error, which is RMSE is root of mean square error. That is mean is, that is nothing but root of 1 by n equal to 1 to n yi minus yi cap whole square. This is the formula. This is nothing but mean square error, as we discussed about. So what is the advantage for this RMSE? So as you see here, I discussed that to overcome this thing, that means to make the same unit, we generally use RMSE. So as you see here, the unit is going to square for MSE. So when we take the root, then this unit going to same as the data point. So some advantages. First point is same unit as the data. Second one is it's also differentiable as MSE differentiable. So for that, take less time to converge to minimum optimum point. And some disadvantage, if you want to know, that is going to it's also robust, not robust to outlier. Similarly as MSE, it is not robust to outlier. So that is the one problem for RMC things. This is not robust to outlier. Now, to avoid this thing, we use MAE. So let's go to the MAE. MAE, which is mean absolute error. How to calculate this? Just like MSE, just we do not take the square term just because of taking square term. Instead of taking square term, we take absolute. So MSE will be 1 by n plus 1 I equal to 1 to n. Just take absolute value yi minus yi cap. So as you see, some advantage. What are the advantage for this MAE? Okay, generally MAE curve will be like that. This type. This absolute curve. This is the curve of A minus B. Okay. So what are the advantages here? The first advantage is as RMSE, it's also same unit as data. Second thing is it actually robust to outlier. This is the main advantage. Why robust to outlier? Because when we take the just difference of 2 points, something let's say x minus y, we do not take any square, so it's actually going to decrease, no, going to less than taking square. So if it's less, then when we try to optimize it, it's actually going to optimize in less time. Okay. And some disadvantages. First of all, it's not differentiable at 0 point. So not differentiable at 0. So for that reason, when we try to use gradient descent, we will face some problem. We can overcome it. We can overcome it. So if you don't know how to overcome it, let's comments in this video, and I will explain you how it's overcome. And second disadvantage is it's as it's not differentiable, we cannot have. Yeah. Second disadvantage is it time takes time to convert optimum point. So it's actually time consuming. Okay. So here I discuss all the things part by part. This is all the theoretical parts for the cost function. So by this, you can know the fundamental concept of the cost function. So by our agenda, we define the cost function, we discuss why we try to use it, and we discuss these things also. We are done with that. Now let's go to the coding part where we use this cost function uh, for how to use cost function for the regression problem. Let's go to this coding part. So I make one GitHub repository for all of you. So which I discussed in my theoretical part. I write up here. You can see that what is the cost function, why we use the cost function. This all the point wise. So before going to interview, if you want to brush up all the things, I will put the link of this page in my video description. So you can take from there the different type of cost function. I have here mentioned the MSE things, this one, the RMSE things, the MAE, and their advantage. Lots of advantages are discussed here. You can read from here and try to think on that also. So this is actually more descriptive notebook for the cost function things. Let's go to the coding part. First, we try to find custom cost function. Try to define the custom cost function, and after that we uh, use the predefined cost function in scalar library, and we compare them. What are the difference between these two cost functions? So as you see here, I write the custom MSE, which is nothing but mean of y true value minus y prediction value square. Similarly, for MAE, is it taking the absolute mean of the absolute value of true and prediction, and for RMSE, the just square root of MSE. This is the MSE form, as you see here. This is the MSE. So this the custom MSE. Now I'm going to make the data set and apply the cost function on the data set after applying the regression model. So import the libraries. This is the pandas library for the data frame. This numpy library for making these values np-dos absolute, this np-dot mean, and this sklearn from the sklearn library we took the data of California housing data. As you see, this is one of the regression problem. From the model selection, we took the print split and regression as our the model. And this is the pre uh, pre-made model pre-made matrix MSE or and MAE from the sklearn we took it. So this is the step one, the load the California dataset here. We load here all the California data. We make this independent variable and dependent variable as X, Y, U, Z. After that, we split this dataset into train and test. This is a general follow-up of the making this model training or things. Now we define our model, linear regression model, and fit on our training data. After fitting on the training data, we make the prediction, which is Y prediction. Now we calculate the MSE. This mean square error we took from sklearn library. This is also took from the sklearn library, and RMSE is nothing but np dot square root of MSE. This is actually taking from sklearn library, but by our custom MSE, the we calculate the custom MSE here, customs MAE here, and custom RMSE here. Now let's compare them. When we print the customs and sklearn libraries cost function, as you see, customs mean square error is 0.55 and sklearn mean square is going to 0.55. So the actually the definition behind the library function also the same, no? So for the reason is going to gives you the same result. So you can see that. So by this also you can see the MAU will be same 0.53 and there is also 0.53. RMSE is actually 0.7. This is also 0.7 for the custom as well as for sklearn. This is going to same. Now, so this is the coding part. How do you use the cost function here? So I put it in the description below. So please let's check that and try to understand all the things. Please read them well. So thanks for seeing my video. Okay, goodbye.